Section 9.3, the t-test for the population mean. Okay, this section is going to seem a lot like the previous section when we talked about the z-test for the population mean. Okay, now recall what the difference between the two are. For the z-test, we need to know the population standard deviation. For the t-test, the population standard deviation sigma is unknown. Okay? So when you're reading the problem, read it to see if they tell you that it's a population standard deviation or if it's a sample standard deviation. Okay? Because if they tell you it's a sample standard deviation, you're going to be using the t-test for the population mean. Okay? And we're going to go through and get our p-values from the calculator. Okay? So instead of using z-test, well, right under it is t-test. Okay? Now, if you're looking at the notes, there is the 5-step method for doing a hypothesis test. Okay? It has not changed. Okay? The steps on going through it, everything is the same. We're going to set up our hypotheses the same. We're going to write our level of significance. We're going to choose, is it a left, right, or two-tailed test. We're going to calculate our p-value. That's going to be the only difference there, how we calculate the p-value. But then we're going to make a decision about the null hypothesis, whether we reject it or do not reject it, and then we write a conclusion. Okay? So everything is the same from the previous section. The only thing that's going to change here is the calculator function to get our p-value. Okay, now, before we actually go through a hypothesis test in this section, one of your classmates emailed me about a particular problem from the homework. It gave you the test statistic and asked you to find the p-value. Okay? So, for instance, they would give you the test statistic, so the test z is equal to, now the example I have is negative 1.25, okay? How they calculated that was this formula right here. It was x bar minus mu divided by sigma divided by square root of n. Okay? That was for the z-score. All that is the z-score. Now, if we wanted the t-score, because they could do the same thing for the t-distribution, that would be a sample standard deviation right there. Okay? Okay, so all they did was already calculate the formula for you. This would go along with the test statistic method, the method that we're not going to go through. I apologize. I thought the homework was only going to ask you about the p-value method, but I guess I was mistaken. So, if they give you a z-score, you're going to use normal CDF, and it's the lower bound, upper bound, and then, since we're dealing with z-scores, 0, 1. Now, if they give you a t-score, like if this was t's negative 1.25, you would have to use t-CDF, and I believe it's lower bound, upper bound, and then degrees of freedom. Okay? Now, some of you may not have t-CDF on your calculator, and you'd have to use a table. Okay? If you go back to the confidence interval videos, I showed you how to use a table when you have your t-values and you look at your degrees of freedom and whatnot. Alright, so now it depends if it's a left tail, right tail, or two-tail test. Let's look at a left tail. So if I were to draw my distribution, I want the area over here in this left tail. Okay? So what I can do is normal CDF, NCDF, just shortening it, my lower bound is all the way over here, so a really large negative number. I could use 100 here. Then this is negative 1.25 right there. So, let's see, negative 1.25, 0, comma 1. And then you would just hit enter. That would give you the left tail. Now, say you wanted a right tail test. You still could have a z-value of negative 1.25, except for the area that it'd want would be this right half. It's just a really big right tail. That's all it is. And then all you do is switch these numbers. So negative 1.25, a really large positive number this time. So this would be a right tail test. It's the right part, right half of where your test statistic is. Okay? And then the last one would be two-tailed test. So negative 1.25 and 1.25, like that. You would have to do your lower bound to your upper bound, but that gives you the area of the inside. You don't want the area between those two bounds. You want the tail ends of them, so you want this green area and this green area. So what you can do is use the complement rule and do 1 minus that, and this would be a two-tail test. I just put it right there. This would be a two-tail test, okay? You get the both ends of the tails. Now what you can do is you could find one tail by doing it negative 100 to negative 1.25. You could do this tail separately, like how I showed you the first time, left tail, right tail, and you could add them together. That is an equivalent way of doing it. But that's what you're gonna do. If they give you the test statistic and ask you to find the p-value, use normal CDF and do lower bound, upper bound. You got to make sure to see what tail test are you doing, left tail, right tail, two tail, because that will tell you how to do your lower and upper bounds. Okay, now let's go ahead and look at this first example. Now, you want to use the t-test when you do not know the population standard deviation, okay? You are testing a hypothesis about some mean, okay? So, our null and our alternative hypothesis should have mu in there. Population mean. Now let's read this problem and determine, do we have the population standard deviation or do we not have the population standard deviation? It says, an engineer at Duracell has designed a new battery for industrial use. The old battery had an average life of 29.2 hours. The engineer claims that the new battery is an improvement over the old since the new design has a longer life. A sample of 20 new batteries finds a mean life of 32.3 with a standard deviation of 3.9 hours. Test the engineer's claim using alpha equals 0.01. Okay? So if we read that, the second to last sentence, it says a sample of 20 new batteries. So we have our sample size. N is equal to 20. Finds it in that sample we have a mean life of, what is it, 32.3. And a standard deviation, so they're talking about the sample here, a sample of 20 new batteries. A sample of batteries has a mean of blank and a standard deviation. So this 20 has a mean of this, standard deviation. They didn't tell us the population standard deviation. Let's see, 3.9. They told us the sample standard deviation. If you review the last problems, from the previous section and you read them, they like explicitly told you the population standard deviation. You were able to word it. In the baker example, he said he baked so many loaves of bread, he's been doing it for a really long time, he knew what the standard deviation was. So that implies he knew the population standard deviation. Okay, here we're talking about the sample standard deviation. Since we're talking about a sample standard deviation, we're going to use the t-test to get our p-value. But let's go ahead and set up our null hypothesis and our alternative hypothesis first. So let's read it one more time. It says an engineer at Duracell has designed a new battery for industrial use. The old style battery had an average battery life of 29.2 hours. An engineer claims that the new battery is an improvement over the old one. So if it's an improvement, the average battery life should be bigger than the average life of the old battery. So, let's see. He claims that it's bigger than. Just bigger than, so that would go here. Our average is greater than 29.2. And this right here is the claim. So we can get the other hypothesis because it has to be contradictory to this one. Well, the null hypothesis always has the equal to sign, but now if this is a greater than, opposite of that is a less than, 29.2. And remember, doing a hypothesis test, we're assuming we automatically assume that the null hypothesis is true, okay? Now, we need to determine, level of significance, alpha. They told us to use 0.01. That should be easy. You just copy it from the problem. They always tell you the alpha. Now, is this a left tail test, right tail test, or a two tail test? We get that from looking at our alternative hypothesis. We look at the inequality sign, and if you were to like draw an arrow, here's the tail of the arrow, it's pointing in that direction, that's pointing to the right. This is a right-tailed test, okay? It's a right-tailed test, meaning if we were to draw this, we're finding the p-value for that little area right there. Okay, let's go ahead and find our p-value. So we're going to use t-test on the calculator. It's in the same location as z-test. You have to hit stat, and then you click over to the right twice to get to this menu. And if you look at number 2, it's z-test. Number 1, or t-test, sorry. The first one is z-test. That's what we were using in 9.2 if we knew the population standard deviation. Here we know the sample standard deviation. We use t-test. Now you can enter in raw data, okay? Null hypothesis, you put your raw data in list 1. Frequency list, just 1, unless you have a frequency distribution table. On the bottom here, you choose left tail, right tail, or two tail test. We're not going to do that, okay? We're just going to use statistics. Now, for the null hypothesis, mu naught is 29.2. The sample mean is 32.3. The sample standard deviation is 3.9. N is 20. And then this is a right-tailed test, okay? You make it match your null hypothesis. Or sorry, your null hypothesis. Alternative hypothesis, not null hypothesis, alternative. So that's what it should look like. And go down to calculate. And here are the outputs you should have. Now, the only one you should be focused on is the p. That is your p-value. It says p-value is equal to .001. So now what we're going to do is we're going to compare the p-value to the alpha value. Remember, alpha is 0.01, p-value is 0.001. The p-value is less than my alpha value. So if the p-value is less than my alpha value, that tells me I reject the null hypothesis. This is my decision that I make. I'm rejecting that this assumption is true. Okay? So, since I rejected the null hypothesis, and this one was my claim, I have evidence that my claim is true. And that's what we're going to write in the conclusion. Okay? Okay, so for the conclusion, you could say there is enough evidence to, now here we're going to support our claim. We're going to write it in terms of our claim. Okay, since we rejected the null hypothesis and the claim was in our alternative hypothesis, we do have enough evidence to support enough evidence. I always forget this part. I always did this in school too. There's enough evidence at the alpha is equal to 0.01, so you got to state your level of significance. There's enough evidence at the alpha is equal to 0.01 to support the claim that, and then you just copy this from the problem. The average battery life for the new design is larger than 29.2 hours. So this would be a good conclusion for this problem, okay? The claim was, the engineer claimed that his new battery design has an average battery life of longer than 29.2 hours. We went ahead and took a sample. From that sample, we used the sample data to calculate a p-value, and from that p-value, we were able to determine that our null hypothesis that the average battery life was less than or equal to less than or equal to 29.2 hours was incorrect. Okay, we rejected that, so that gave us evidence to support our claim, because the opposite of that was the average battery life was greater, and that's what exactly what the engineer is saying. As you can see, this was very much like the 9.2 when we were doing the z-test. Okay, only thing that changed was how we did it in the calculator. Let's do one more example. It says nationwide registered nurses earn an average annual salary of $69,110. A survey was conducted of 41 California registered nurses to determine if the annual salary is higher than $69,110 for California nurses. The sample average, let's write that down, sample average was $71,121. With the sample standard deviation, so right off the bat, they told you sample standard deviation is equal to 7,489. See, and then they told us our N. N was 41 nurses. let's see, conduct an appropriate test to test the claim that the mean salary for nurses in California is higher than the national average. Okay, so right here, we already have an average that's bigger than our population average. Let's look at our null hypothesis and our alternative hypothesis. A survey was conducted of 41 nurses to determine if the annual salary is higher than. So we are claiming that the salary in the salary of California nurses is higher than the national average. So that is our claim. In higher than 69,110 is just a greater than symbol, no greater than or equal to. Okay, so that means here should be, here's our claim, right there, that California nurses earn more than the national average. So we're going to test this claim. Now, like I said, right off the bat, it looks like the claim is true. But just because we have a sample average that's bigger than the national average right now does not mean that our claim is true. This is the point of a hypothesis test. The sample data may not be enough evidence to refute the validity that it is less than or equal to. It may not give us evidence for our claim. Let's go ahead and find out. So, alpha equals, what do they say? Test the claim. Oh, they don't even give us an alpha. Okay. So, if they don't give you an alpha, just assume it's 0.05. That's most widely used right there. Now, if we state the kind of test that we're going to do, we look at the alternate hypothesis and we look at the inequality symbol. Inequality symbol, again, it looks like it's pointing to the right. So this is a right-tailed test. Since it's a right-tailed test, we're still finding this little area to the right over there. And we're just going to use t-test here, just like we did on the last problem. We know the sample standard deviation, not the population standard deviation. So we're going to use t-test. Now hit stat, click right twice to go to your tests. Go down to number 2, it's t-test. Go to statistics and type in your data. So X bar up here is 71,121. Mu naught comes first. 69,110. Now X bar is 71,121. Sample standard deviation is 7,489. Our N is 41. And it is a right-tailed test. And here's how it should look. 69,110, that's our null hypothesis. 71,121, there's our X bar. Sample standard deviation, 7,489. And then sample size 41, right-tailed test, calculate. Okay, so we get a p-value of 0.046. 0.046. Again, if we look, our p-value, which is 0.046, is less than our alpha value, which is 0.05. We come up with the same conclusion. Reject our null hypothesis. Okay? So that just means that, remember, we assume the null hypothesis is true. So this is saying California nurses don't earn or earn as much as 69,110. We assume that this is true. However, our sample data shows that it should not be true because we shouldn't end up with a sample like this unless that this is false. So since this one is false and here was our claim, we can support our claim. Now, if this one was our claim, we would say there's not enough evidence to support our claim, such, and such, and such. Okay? Now, before I go ahead and erase this and write our conclusion, let's talk about an interesting point. They didn't give us an alpha value. We picked our alpha value here. If we would have picked 0.01, this would have been 0.01, and then we would have had a different decision. We would have said, do not reject the null hypothesis, okay? So, picking the alpha value is very important in what field of study you're in. You usually want to keep it pretty consistent, okay? Because they could result in different conclusions, all right? Now, in problems, I'm always going to tell you what the alpha value is. I'm never going to not tell you what the alpha value is. This problem we got to pick. So, if I switch everything back to how it was, I mean, I'm going to erase it in a bit, but I want you guys to see how it was. So, this is what we came up with from our hypothesis test. So now we need to write our conclusion. Summarize all this workup. So there is enough evidence at the alpha is equal to 0.05 level of significance to support the claim that the average salary of California nurses is greater than $69,110. Okay, so that would be a good conclusion. Now, let me just show you the slight difference if we did not reject the null hypothesis. What would change in this statement? Okay, remember our alpha value was 0.01. There is not enough evidence at the 0.01 level of significance to support the claim. So remember, if we change it to 0.01, our p-value was not smaller than our alpha value. Since it was not smaller than our alpha value, we would not reject the null hypothesis. Our claim was the alternative hypothesis. Since we could not reject the null, well, we don't have enough evidence to support our claim. See, we always want to write it in... There are multiple ways of writing it, but a good way of writing it is to write it in terms of your claim, okay? You either have enough evidence to support your claim or you don't have enough evidence to support your claim, and that's how you're going to write it. Now, in the next section, 9.4, it's going to be exactly the same thing. We're going to write hypotheses, we're going to write the level of significance, right tail, two-tail test, but it's going to be for proportions, okay? There is a test in the calculator that you can do. It's one proportion z-test.